In a circle with center B, find the area of the segment formed by the chord. So the segment that is formed by the chord is this portion here. And this is our chord. Now to find the area of the segment, area of segment, this is just equal to the area of the sector minus the area of the triangle. So the sector is this whole portion, this one to this one. Okay. So the sector minus the triangle here is just equal to the area of the segment. Now let's solve for the area of the triangle first. It's given that the triangle here is a right triangle and one of the legs is just equal to 20, which is the radius of the circle. Therefore, this other leg here is also equal to 20. And now we can solve for the area of the triangle. To solve for the area of the triangle, that is just equal to 1/2 base times height. We're given here the base, which is 20, and the height, which is also equal to 20. So that is 1/2 times 20 times 20. This is just equal to the area of the triangle is just equal to 200. And now let's solve for the area of the sector. The formula in solving for the area of the sector, so the area of the sector can be solved as the angle, the central angle divided by 360 degrees times the area of the circle, which is pi r squared. And we're given here the radius, which is equal to 20, this one here. So we just plug in the value of the radius. We have 90 degrees over 360 degrees times pi 20 squared. Since 360 is just divisible by 90, so this is just equal to 4. So we have 1/4 times pi times 400. So the area of the sector is just equal to 400 pi over 4, which is just equal to 100 pi. And now we already have the area of the triangle and the area of the sector. We can now solve for the area of the segment. So the area of the segment is just equal to 100 pi, that is the area of the sector, minus 200, the area of the triangle. And this is just equal to 114.15. We're given here this figure, a triangle with mid segment and a trapezoid which has a mid segment KO. And we're given the mid segment, the value of the mid segment ln equals 22. We just need to solve for or to find KO and JP. So from the midpoint theorem, ln here is just equal to 1/2 of KO. Since we're given the value of ln, we just have to substitute 22 here equals 1/2 KO. Then we can solve for KO. KO is just equal to 22 times 2. So KO is just equal to 44. And now let's solve for JP. KO here is the mid segment of the trapezoid JLNP. So let's draw that trapezoid. So we have here J, K, L, N, O, P, and we're given Ln equals 22, and we got the value of KO, which is 44. And now let's solve for JP. Now to solve for JP, the midpoint or mid-segment theorem, we just have to divide the sum of the two bases of this trapezoid, so we can solve for KO, but KO here is already given, so that is KO equals Ln plus JP over 2. Okay, but KO is already given. Let's move here. So KO is 44 equals Ln is 22 plus JP over 2, and then we multiply both sides by 2. We have 88 equals 22 plus 88 plus 22 plus JP. And now JP is just equal to 88 minus 22, which is just equal to 66. So KO is equal to 44 and JP is just equal to 66. Let's solve another problem here. In triangle EPR, the measure of angle P is equal to 45 degrees. The measure of angle E equals 63 degrees and P is equal to 22. Find E. So let's draw triangle EPR first. So this is EPR. It's given here that the measure of angle P is equal to 45 degrees and angle E is 63 and P is 22, the opposite side of angle P, and this is side E. So we need to find side E here. So in this case, we can use law of sines. So that is sine P over P equals sine E over E. And then we can plug in the given values. So this is just sine 45 degrees over 22 equals sine 63 degrees over E. Therefore, E is just equal to, and when we cross multiply this one, E is just equal to 22 sine 63 degrees over sine 45 degrees. And this is just equal to 27.72. So that is the value for E.